Okay, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon as we try and figure out the future for smarter buildings. It's really good that you're with us today. In case you're wondering who we are, our profiles are listed on mondaylive.org. And also just to point out that views expressed here are personal and not of any company or organization. Just keep that in mind. And let's make it interactive by using the Zoom chat. And if you need anything from the slide deck that I'm showing, it's also available on the homepage of mondaylive.org. So this being the last Monday of November, we're going to continue talking about composing digital twins for real ROI. Really looking forward to this conversation. Our agenda is normal news and trends, then talk about composing digital twins. And today we're going to be sort of focusing on decomposing existing building systems. And we'll get into that in a moment. Looking forward to the discussion there. But before all of that, I do want to wish everyone a happy Thanksgiving this week. So hopefully if you're traveling, you're going to be safe and all of that stuff, and hope you have a great, wonderful holiday filled with joy and gratitude. There you
go. Well,
sorry?
said well said.
Okay. And I'm going to hand it over to Ken.
Thanks, Anto.
What's going on, Ken?
Oh, thanks, Anto. As always, lots. Start up in the left-hand corner like we usually do. Tracy was up to Vegas at the Snyder convention that was up there, and part of it was a tour to a server complex, and he was extremely impressed with what was going on there, and he shared that in an article. I forgot he wasn't going to be here this morning, so I thought he would be talking to that. But it fits well as our blocks that we are trying to put together. We're building these villages from our reconstruction, our decomposing and recomposing. But it depends entirely on these data centers and how that information is transferred about. Below that, we've got our summary of last Monday's Zoom, and that's decomposing to compose the Lego block future of the smart buildings. I think that's been a good focus. It lets us take something that is virtual and treat it like something that is real. And we have to understand that the pieces of all of this need to fit. And I've been trying to encourage the industry to also, as they write and share their stories on automated buildings, that they think about writing their posts as decomposable and composable, so people can actually use them and that they actually fit and interlock with each other, like the example of the server story, and then the story of how we're building villages out of these composable blocks. And I think we start to have to tell our stories that way too, and make them, each post is a composable, decomposable. There's information in there that we can take out and reuse in our own for our own purposes and recompose it. So I think that's a good theme, and it prompted me to write the decomposing building cloud capabilities into Lego like blocks for reuse anywhere. So we've got this common concept going, and trying to get some of this stuff into the GitHubs, and it's a good way to deal with it, I think, and it's kind of a fun analogy, and it seems to be gaining some speed. At the bottom, on a different note, we've got what's going on, who's buying who in the industry, and that's always an interesting thing. But there is a lot of movement going on, and we have a session in Vegas because we thought it was so important that so we've got succession, sale, or scale. What's your next business? And that's going to be a lot of fun because Brian Turner's there and Scott Cochran, and both of them have come through this transition. And Kerry has actually had quite a bit of involvement with bringing companies from private ownership to IPOs. So anyway, it's that's looking forward to that in Vegas. I asked AI to draw a picture of what we were doing, and it came up very confusing and very clouded and lots of very colorful, and I think it nailed it. What I liked best is it started with Iman pointed out, he brought out that with the block thing that we've been trying to deal with that for quite a while, and that he sent this stuff and it had black and white blocks. That's how old it was, and it was like, oh my God, that's what's happened is we've come from black and white Lego blocks, and we're now I've got colored ones, and they actually connect. You can actually plug a gray block into a colored block. I think I'm a very visual person, so I kind of like that. And so it started showing that, and it started showing some of the things, and a lot of this. I was leading AI, but I was totally amazed at how much it captured and kind of just turned this into an explosion. So I really like this particular graphic. And then what I asked it was, what does natural language, how's natural language going to touch into this? And that I think was an important piece because that showed me that how important all the work we're doing is for natural language. And I think ultimately that is our goal, is that we can just simply walk up and ask what's the performance of the chiller, or what's happening, or what data, or what's going on in room 6, and just talk to the system and it'll actually bring us back. And like everything that is moving ahead now in technology, it in the final analysis, it always ends up being incredibly simple, but it's terribly complex to make it terribly simple. And I think this graphic kind of shows a bit of that. And there's a bit of discussion there about how important natural language is. And I think that could be some of our future discussions. Anyway, back to you, Anto.
Okay, thank you. Thank you, Ken. Rick is not here. I believe he's got some personal logistics issue, probably related to Thanksgiving. Wondering, Kimon, could you just do a really brief read on what's going on in the semantic building? You tend to
Sure.
be on that call, just briefly.
Yeah, there's been quite a bit of activity relating to, in fact, we're starting to post some of the work on GitHub of what we've been doing there. And we're getting ready to actually post a sample model that's related to semantics and ASHRAE 223P to get input. And we've had conversations with Paris 2, who's from NIST, relating to ASHRAE 223P. So we're trying to capture all that logic and knowledge into actual examples and put it on GitHub, including with models, and encourage others to do the same so we can start testing things out. Because I found over the years that we can talk forever, but until you actually try some kind of a hello world version of things, you end up with a lot of meetings and a lot of talk and no results. So we're encouraging others to do that. And it also, the semantic group also crosses over into the other group discussions that are happening. So for example, with digital twins or Cloud BIM, we're posting stuff on Cloud BIM relating to the semantics. So the C4S group, B groups are separate boxes here, but I see it as basically it's a graph. Everything's connected to everything, but obviously we have to start piece by piece. And we're also preparing for heading to the AHR ASHRAE, the winter conference in February, to present a lot of this work. There are several sessions there relating to the C4SB work.
Okay, great. Thanks. And I agree with you. The fact that these working groups are basically interacting with each other because the subject matters obviously interact with each other, I think is one of the most interesting things about the what's going on at C4SB.
Yeah. Actually, they're all like Legos, right? If we go back to the Lego analogy, all of these need to
Composable, yeah.
compose and decompose the groups.
Yeah.
So it's, yeah, just thinking in those terms pretty much carries
Okay.
across to everything.
Okay. Let us move on. Anything else from anyone to bring up?
Maybe briefly, if that's okay. There's a conference, a series of two conferences. Are we at that section yet? There's the two conferences I want to mention quickly. They're
Sure, go
coming up.
ahead. Yep.
In November, there's two conferences in San Diego where I'll be presenting at both of them, actually. One of them is called the San Diego Tech Conference and Expo on December 5th. And the other one is relating to AI and urban AI. It's actually an AI conference that I've never heard of before, but it's a huge conference, like 15,000, 20,000 people. It's the Neural Information Processing Systems Conference. It's where supposedly ChatGPT was first presented. So I'm kind of diving into that to see what angle there is from a Lego perspective, I guess, to connect what's going on there at the Urban AI
Cool.
conference.
Do you have
Cool.
URLs you could share on those, Timon?
I'm sorry, what was the question?
Do you have URLs that you could
Yeah,
share
I'll
on
post
those?
them in the chat. Yeah.
Yeah, that'd be great. Thanks.
That'd be great. That'd be great. All right. If there's nothing else, we shall proceed. Talking about composing digital twins for real ROI. We've been on a bit of a journey this month. We started off talking about whether we can be composing master format divisions. That was kind of an interesting conversation as a lead from our previous month. We talked a little bit about how silos could be the things that you're composing, sort of using that sort of framing that we've been talking about the last couple of years here. And Doug also brought up this the concept of the digital twin capability table that came out of the Digital Twin Consortium, which is also another useful way of thinking about how you can break up big things, sort of monolithic thing, into capabilities, which is really the sort of the unit of interesting things, which is really the focus of this. We spent a week talking about whether there is actually one or multiple digital twins, and we decided that there are multiple digital twins. And last week we talked about this sort of decompose to compose with this sort of wrap up that Ken wrote up, which is great. And we talked about this on our planning call last Wednesday, and we thought that this is all fair games, that this is great. But we sort of wanted to focus on the flow and just make sure that we understand what this decomposing is all about. And we sort of decided that we really need to dig into the decomposing a little bit more, because I don't think we didn't think we're there. We kind of need to go one step further. So the discussion today is really about decomposing existing building systems. So sort of the framing we sort of want to think about this is that we spent the time decomposing buildings and complex systems into Lego bricks. But how about the actual Lego bricks themselves? How do they work is kind of what this slide is all about, right? And the way I think about it is that a Lego brick fundamentally is a brick. Right? What you do with Lego is you build it into a wall, and what you see is just these red things or whatever the color that you use. Right? This is, to me, this is equivalent to the capability that we're talking about. This is the essence of what the brick is. The brick is a brick. We all understand what a brick is. Right? So the brick is the capability. Being a brick is the capability. Being able to raise something by whatever that height is. That is the fundamental capability. Right? And we know this works because we can take bricks and we can pile them up on top of each other. But obviously, if you make them out of plastic, they all slip around, they don't stay in place. So this is why back in 1958, a Danish guy by the name of Christensen patented the Lego mechanism. And essentially all the Lego mechanism is all about is appending these studs on top of these bricks, right? So that they can facilitate the sort of the modularity of these bricks so that things can plug into it. Because at the same time, they also created the anti-studs, which are underneath. So the two just plug into each other, right? So there's the brick, which is actually the thing itself. And then there's the studs and anti-studs, which are the things. It's got nothing to do with being a brick. It's purely got to do with how a brick can be plugged in a standardized and interoperable way with any other brick in the universe. That's really what the studs are. Right? And to me, that's really what we're talking about. The capability of a function, whether it's a VAV or air handling units or whatever, is really this thing on the left. Right? And in our planning call, Steve was we were having discussions about sort of the experience that Steve was having in his company as a vendor. Steve, I hope it's okay for me to say this, but
Yeah, absolutely.
Steve was recounting the fact that they at ISMA are developing some new products, and they're doing it, by the sounds of it, very, very appropriately in terms of technology. They're using Linux, they're using cloud native sort of components, CNCF bits, and obviously they've implemented the application of whatever it was. I can't actually recall what the controller was, but it had some special features and it had some special things that enabled it to connect to the hardware, blah, blah, blah. All great. That is this. What Steve didn't do, or what ISMA didn't do, is these bits. Is the bits that make that fundamental capability of the product or the thing be able to be plugged in and be able to be expanded into other applications that's not necessarily obvious to the reason why the product was designed. So the way I think about, how do you do this, is that fundamentally what you built is this one in the middle here is the brick, it's the function. So you would have started, in Lego sort of analogy, with a lump of plastic, right? You obviously would have started with code. And really what you did is you use that to build this. And what we're sort of saying is that that's great because that is the capability that you want, but extend it a little bit more and add these little interfaces that makes that brick able to work with any other brick that is similarly constructed. That's kind of the framing, right? So it's fundamentally the same thing. So that these sort of the things that you build, rather than just being standalone things, they become things that can plug into each other and be whatever they can be. So that's kind of the framing, and hopefully that sort of works a little bit. I'll stop for a minute for some comments, maybe from Steve.
Yeah, so the what do you call the
Studs.
The studs, okay, right. Yeah. So in the case of ISMA, all of our products communicate either BACnet or Modbus. So why wouldn't each of those be considered a stud in your example?
Because because BACnet can only talk to other BACnet stuff. So think about BACnet as being red bricks. Mm-hmm. It can't talk to anything other than BACnet. The purpose of this mechanism that we're trying to adopt is an interface that can talk to any and everything, not necessarily something that is sort of inherent in how.
Yeah, so I get the concept, but I guess the confusion for me is when I look at the Lego blocks with the 6 studs, right? I can easily bring myself to say, okay, well, we support BACnet and Modbus today, and we're adding MQTT as an example. So now I've got three things. I could
No,
potentially add
those are
four,
not interfaces that can work with everything. Those are very
but
specific interfaces.
are you considering? But then if we had a brick that had an API that was published and was developed against a standard, is that the correct stud? What is the correct stud, and do I need more than one? Because the way you're presenting this, it appears that if I want to be able to talk to everything, I need this open API that can talk to everything, and then I'm done.
The rationale of using the Lego model is
Right?
that there is only one type of stud.
Okay, that's what I'm trying to get clarity on. There's one type of stud that will work with everything.
Yep.
Okay.
So maybe we should discuss that very point. Just open that up for discussion.
Yeah, whether it's Kimon or
Oops. Yeah, I had my
love to
mute
see
on.
what you
So
guys think in this regard.
you can have a stud, but you can also have patterns of studs, right? Just like you have here, you have one that has one stud, another one that has 6 studs, and then you have other blocks that have other type of capability. They might even have a electrical motor attached. In fact, in Lego, they have those actuators and things that plug in as well.
Right.
So I think there's that. If you follow that pattern, then you can plug into different things, whether it's 1 stud or 2 studs or 6 studs or the whole plane of studs. And then being at that exact size allows you to do that. You can't kind of fake it and say, well, mine's 1 millimeter bigger, or it's not really round, it's kind of oval, or it has a special proprietary shape that you can only use a certain tool to open up. Or the other example I use sometimes with Legos is you can't also use super glue to glue them together, so you can never take them apart, which gets back to the decomposability, because if you don't like that motor, you need to be able to switch it around.
No, what do you say of this analogy?
Sorry, was that me?
Yeah. What do you think of this sort of path of?
I mean, it's clear to me. It just means what is the stud, right? What's the definition of the stud? And do we risk the challenge of creating another standard?
Right.
A little bit back to Steve's point, right? When things like BACnet and Modbus and things are around, and I understand your point as well, but is this just, the old comic strip? Look, there are 14 standards. We need to get all together and fix that, and we end up with 15 standards.
Yeah, I think the interesting question is standards at what plane, right?
Sure.
Because you could say that we've spent the last 30 years coming up with BACnet and other technologies that actually solve this problem at a certain level.
At a level, yeah.
And in fact, we have interoperability amongst different systems, albeit a narrow range of systems. For instance, HVAC controls, lighting controls, fire alarms. Other things that are very tangible to building automation have been included there over time. Some industrial automation things. But what we're missing with something like BACnet is the ability to have this light touch, higher level interoperability between silos, right? We haven't really skinned that problem at all. And if that's what we're reaching for with, the studs shown in the picture here, that makes a lot of sense to me. But to claim that we don't have interoperability today, we do have it. It's just you have to define where. And by the way, it was a really long, painful process to get what we have today, which, by the way, also makes going to the next step much easier.
Yeah. So Jim, to your point, in the case of ISMA, they have made significant investments in both BACnet and in Modbus. And as you know, Modbus is still very popular on the industrial side. It's kind of had a rebirth now in data centers. And so even though it's much older than BACnet is, it hasn't, by no means has it gone away. And so the fact that we have that plug and play flexibility in all of our products today allows us to, at least within the context of HVAC, to be available to other bricks.
Doug,
But Steve, I
wonder if
think
you,
I think that nails it. It's in the context of lower down things. And
Right.
if we're searching for a broader context, that's what motivates this discussion, to my mind. Sorry.
Yep. No, I agree. Yeah, I'm glad we're talking it out, because I just want to bring some better clarity to what the problem is that we're trying to solve.
Doug, I wonder if you can sort of put a system modeling layer to this conversation, because if that makes sense, you're muted.
Yeah, I think there's definitely interoperability at different layers, and the layers with MQTT and BACnet, that's really at the communication protocol layer, and there's not going to be one standard for that, because each of those protocols is best suited for specific use cases. I think what we're really talking about is the layer above, which is the application layer.
Right.
And that's really where the capabilities comes in, is at that layer. And so that's where it really doesn't matter if you're using BACnet and QTT, as long as that's just used for, as your communication protocol. But what you the studs that I look at here are relating back to how you are specifying your capabilities. That's what's missing. The BACnet and MQTT are not standards that allow you to model and standardize capabilities. So it's leveraging those communication protocols to support communication amongst different systems, but then those systems have to be able to say, hey, this is what I do, and this is what I need. Who out there has what I need, and who out there needs what I have? That's I think what we're talking about. And so the brick is about what I can do, and the studs, and again, this is a simplistic way of looking at things, but the studs are really about the handshake or the ability for other systems to discover what you have to have. And if it's needed, it has the ability to create that connection between those two capabilities. And that's what I think would be locking those two bricks together, would be the agreement that says, I want what you've got. Let's do business together. Let's support each other.
I think that's it, Doug. And I think to Jim's point and everyone else's, I mean, we just have this tendency, I believe, in our industry to commingle those two things and try to package up everything as a standard. And we need to just forget, nobody cares about the plumbing. Imagine if somebody was saying, like, when you build your house, you had to have copper pipes, or you had to have PVC or whatever. Who cares? It's plumbing. As long as what flows out the house and I get clean water into my house, I don't care about the plumbing, because it's literally just plumbing. So I made a point over the weekend. There was a Start with Smart group on WhatsApp that just kind of exploded from like 3 people into 150 people from the industry. And we just wrapped it up because we saw in 2 months' time, we saw 7 years worth of stuff get compressed into 2 months. And it at the end of the day it became a religious standards war. It was amazing. It was an amazing thought experiment. It was Kirby. I think Nick Kirby, or I forgot his name, but yeah, he started this thing. It's called Start with Smart. And I just sat back and just watched it just divulge into this standards war. And I made the point when I did my sign off post today. I'm like, this is amazing. I said, but everything that we're interoperating with three different control systems: Danfoss, ALC Web Control, Tritium. And you know what we're using? Ajax and XML. And it's like, oh my God, XML is not composable, or it's not protocol agnostic, or OBIX doesn't work, or it's old school, and that's not the right way to do it. Yet there's many of us in this industry doing this, and we use what is available to connect and get the freaking data out of the BAS, and then we keep all that other stuff on the top side because that's where it belongs.
I think you've nailed it, Keith. And I think the key thing to mention is that the subject we're supposed to be talking about today is existing buildings, right?
Yes.
And how to decompose existing buildings. And the fact is that those of us who are practitioners in this business today do that all the time, as Keith said.
All the time.
And some of the new discussion that we've been having the last few Monday Lives has been about how to do it right when you're starting with a clean sheet,
Yeah.
right? Which is not what we're confronted with on a daily basis when we're actually in the business, right, Keith?
Yeah. I'm onboarding 6 new customers in this short Thanksgiving week. 3 Tritium, 1 Schneider, a JCI, Metasys, and a Tritium. And they're all using XML and proprietary protocols or BACnet over IP. I don't care. I'm onboarding 6 customers.
So I do have a couple of other slides which actually tap into what Jim's talking about, because we're talking about existing buildings and existing products as well. So I've seen this. So, well, how about existing buildings and products? So this is a bit of fun. I asked AI about this, about decomposing existing buildings, and this is what it gave me. So I thought, you're taking me too literal. So that's not what I meant. I meant this. So if we were to decompose buildings today, we're not going to get bricks that can plug into each other. It's actually the point that you're making, Jim, right? You're going to get things that do whatever they do, right? So how do we make this world look like the other world? And I actually think we already know how to do that, because there is always an ecosystem of connectors and plugins. In the Lego world, you can buy these things. You can buy a single stud, believe it or not. You can buy online a single one stud and get it delivered to you. Or you can get tapes of studs, or you can get websites where you can get all of the different shapes and sizes. You can, because if you want to, adapt one brick to be another brick, right? So in our world, I don't see it any different to this, because what Keith is basically saying is, this is the kind of things that we do. We create things to plug things into each other, so that we can end up creating these studs, not in the product, but you're on top of it. Sort of.
So are you arguing for gateways and middleware? I mean, is that where you're going with this, or?
I'm arguing that if you were, the right way of doing it is this way.
Yeah.
You put it in the product, right? Mm-hmm. And the argument here is that doing it this way does not put any excessive burden on the vendor, because it can be done as part of the product development process. Yep. That's kind of the way it is. So, but for products that don't inherently have those capabilities, then you go down this path.
But there's almost like this disdain for doing something that's completely normal in other disciplines. I mean, the definition of a protocol gateway, and IT they do this all the time with token ring, dissimilar buses. It's called a network gateway. It translates one protocol to another. That's why you all know I will never shirk away from using the term gateway. It's not a bad word. You see the almost disdain. You mean you want to use gateways for that?
Keith, I was afraid to mention it, because I feel like I'm going backwards 3 decades, right?
That's what I'm talking about, Steve. It's like it's not a dirty word. IT people do this all the time. How do you think that 1970s cash register is working inside Walmart?
Right.
It could be IBM token ring. There's a gateway there. Other people don't freak out over this. So I'm not going to call it an adapter. I'm not going to try to soft pedal or sugarcoat it. It's a freaking gateway, and that's what its purpose is. And I'm never going to shy away from that, because guess what? I'm getting the data.
Yeah,
Mhm.
right.
The
Exactly.
point is here is that the gateway is effectively, in our analogy, the stud, right? It's the thing that provides
Yeah.
the
If only
way to connect.
we would fess up to using that word and that terminology and call it what it is. Unashamedly. You know, I talk to IT departments all the way. What are you gonna? You got your standard MQ, use the MQTT? Nope, I got a software gateway. You know, I'm like, what's your alternative? Yeah, I'm using a gateway. What about it?
You know, I think that that's actually a really interesting point in that, you know, where did gateways really get a bad name? And the answer was it was in big interoperable systems where no one could maintain the gateway.
Exactly.
So where's the gateway at is the question. And if it's up by your application, which is where yours is, Keith, your value proposition, which is closed-ended, is responsible for maintaining that gateway as part of your service delivery.
You know why I'm laughing, Jim, and you probably already know. Our dirty little secret is we're really using gateways at the internal level. All
Right.
the company, all the big major controls companies are out there doing that, right, Anno?
Well, so I was going to say, Keith, we've actually changed the parlance. We don't use the word gateway for those reasons. We call them edge devices. And
Yeah.
IT guys like edge devices
Yeah,
because
but
it's
what's
like,
the active component that's doing the heavy lifting, right?
oh, yeah, what magic that happens in the edge device.
We're still building control, folks, and I'm not going to name names here. They're still running 1970s and 80s protocols on the wire.
Yeah.
Surprise. What do you think we've been doing? Haven't we all seen this? You know, the Delta 1000, Delta 2000, Delta 4000, Delta 10,000. It's still running the same old protocol back on that 1970s DGP panel that's been sitting there for 50 years. You're not, it's like the bell tone, man. You're not going to change that.
Keith, did you had your milk today?
I mean, seriously, it's ridiculous. Like we're really doing this anyway. You're using gateways anyway.
Edge devices, Keith.
Yeah, edge devices, or it's a. I'm sorry, I don't want to offend anybody.
But actually, in the Lego analogy, isn't it just the Lego piece that is the platform that you start building your building on? And also, isn't it the where you have an actual motor, a Lego motor that plugs in, and like I like the edge device. So basically, we need a whole bunch of edge Lego devices. Isn't it just as simple as that?
Edge Lego devices. You lost me
Well,
there.
imagine starting, if you're gonna build something out of this, the first thing you need is that Lego piece that is like a mat that has all the studs on it, and then you put your blocks
Oh,
on.
you mean the yeah.
Okay, so that's how you get started. You build whatever you're building, and now I want to add an actuator
But
to it.
on that, just one point, on one of those platform things, I don't know what they call the flat bit of Lego,
I don't speak
right?
Lego either.
Yeah. That can only work because it has studs all over the place.
Correct. That's maybe what we need. We need these things that they're talking about that have studs all over them. And they can call them edge devices. They can even call them gateways. Who cares?
Yeah, I think that there's always a danger in analogies and I think we're starting to get to the edge of using this analogy.
Yeah.
Yeah.
Because the thing is the Lego is physical, obviously, and it's bricks, right? So you could think of building a house using Lego, but that's not all we're talking about at all. We're talking about it from a systems perspective. So get a little dicey.
Although your image onto the decomposing building that you showed earlier is kind of interesting. If you think in terms of, so we have the perfect scenario if everything was made out of Legos, you can decompose and break the whole thing apart, right? But the reality is not that. You'd have to kind of tear the whole building down to get to that perfect. And you don't want to do that. Like Keith said, you go in strategically and you use what's there and you build on top of it.
We are, And the fact of the matter is, and we're the only ones who seem to care about this stuff. We think that our customers care about this stuff, and they don't. They don't care. They don't care. We don't even let our partners and customers have conversations with their IT department. All they do is refer us to give me the name and the number of the CIO, and that's it. We'll take it from there, because they're like little kids running around with scissors. They're gonna fall and hurt themselves. So we don't even let them have that conversation anymore. And nobody cares. Who cares? It's FM. And the F doesn't stand for freaking either. I'm sorry, man. I'm almost 64 years old, so we gotta get this thing wrapped up. I literally don't have time.
Jeez.
It's time to pass it on to your daughter, Keith.
The other thing I was just going to pick up on with Ken, a few weeks ago, you were talking about the actor model. Toby wrote an article about the actor model, which is kind of a way of thinking about distributed computing. This right here is an actor, right? It does something. It's designed only to do something when it's told to do something. It can't do anything else other than that thing that it does, right? So it needs input, which can only come in through external things like studs and other things, to connect to other things, to tell it what to do, and for the actor to produce stuff to be consumed. Just thought I'd bring that up.
So on to listening to all this, one could argue that the IBB is the next generation gateway on steroids. In other words, it can be, it doesn't have to be, but it can be the gateway for anything that's out there, right? And then because the applications also live on it, once those applications that can plug into whatever version of gateway functionality they need so that they can operate. But then the applications are able to communicate to each other through what your through APIs or through the
studs.
It's a
mechanism,
right? A network appliance. To your point, we can call
the mechanism that is represented by the studs.
That's not a dirty word.
Yeah, and maybe Ken, that the platform, the Lego platform, maybe that's actually quite an important thing, because the fact that has all of the studs means that you can instantly start with that. So maybe the IBB is effectively one of those.
Isn't it maybe the opposite? It's not the bottom of the model, it's the top of the model.
Right.
So I've got the base, and then I'll build all my pieces, and then I stick this thing on top that actually spans over a bunch of vertical blocks of possibly protocols, and we can even we call it an edge device.
Well, I would have thought that the platform would be the foundation, and what you're talking about, once you have lots of bricks and then you can sort of connect the tops of it, that's almost like that's what your dashboard is. That's your single pane of glass. If you're into that kind of thing, is that you're extracting data from the various bricks into some user experience that is being used to operate the building.
It's the ultimate cloud connector, isn't it? That's basically what it is. The purpose is to take all of those blocks below,
right,
and basically put it into cloud native. Am I missing something?
Yeah, and again, this is the point where the analogy starts to break down.
Yeah, right.
Yeah, but I mean, Jim Lee has institutional knowledge of this. They created a Symmetrics backstack, for God's sake. I mean, they've been doing this since 1995. I mean, it's just this. We know what this looks like.
We do. But the only thing I'd say, Keith, is that some of the new innovations will make things better in future. And
Yes,
some of the work that Anto's been doing on connection profiles,
right.
I mean, that's really designed to
And
be
you
the
would
stud.
backnet over backnet SC.
Yeah,
Right.
that's what I was suggesting. Is that that's where I was going with the connection profiles. Is that's a stud for my way of thinking.
Where does
It
the
is.
API fit into all of this, in the analogy? Can you do that,
With the
Anton?
what?
The
Didn't hear.
API.
API is effectively how the stud works. To be a stud, right, you have a stud and the anti-stud, right? If you think about it that way, then one of them is an API. The stud is the API that's calling something. That's kind of, again, the analogy starts to get weird.
Well, I mean, here's something that's not an analogy. Okay, so everybody knows that I was literally making some flight arrangements on you know, American Airlines, I believe. And it was like, we got your schedule. Your flight's coming in at 7 p.m. Eastern time. Would you like to book a car with us? I guarantee you that American Airlines IT department did not contact every single friggin' car rental agency to work with them on getting a standard API together. And there certainly isn't any third party vendor that's setting up some sort of brick or haystack ontology for car rentals. No, they published their friggin' XML. It used to be called a WSDL file, a web services description language. They published their WSDL 20 years ago, and they've been running with that ever since. And they never have to talk to each other. Why can't we do the same?
The only reason I think that's it. I'm sorry. Go ahead, Anto.
I was just going to say the difference is the dynamics of it. That situation is pretty static. An airline booking system would have make calls to somewhere where all of the our inventory is stored, basically, as a service, and it doesn't change. It doesn't change every all the time.
Well, that's what the interface is good for, but I guarantee you stuff changing underneath it. So you're doing XSLT or transformations with that stuff, which is we've incorporated. I mean, that's what connectors do. That's what IT departments do, which was the whole purpose. My point is that the other industries in this world have got this stuff together, been using it for 20 years, and we're still trying to build the perfect standard connection that everybody agrees with. And other industries have just moved on and started conducting business.
I think that's an excellent point, Keith. And the thing that I would say here is that this is where there's a slight difference between what we've been doing and what they do, which has been a stumbling block. I'm not saying that we shouldn't be able to solve it, but let me put it to you this way. If you look at an airline reservation system, there's plenty of complexity there. There's no question about it. It's not necessarily less complex than what we're doing.
Right.
But it uses traditional human rules and language around processes and functions as to how people interact and what they do. The fact that you're flying, it's a presupposed behavior that understands that if you're flying in the modern world and you're landing at a rural airport, you have got to rent a car, right? I mean, that is an understood thing. Now, when we go to physical world analytics and we look at the kinds of data that we're requiring, there's not necessarily as tightly coupled a preconceived notion at the application layer as to what we're going to do with that data. There are more degrees of freedom that aren't as locked down. And I was looking at the comments. I'd say your name, Amol, or basically commented that, why don't we have discovery services? Well, BACnet has had discovery services for 30 years, right? Who is, I am, who has, I have. Now, what's wrong with that? And why doesn't that mesh with your airline reservation car rental thing? And the answer is that the context around what those things can do is not as well understood. And it's because there's actually more variable context with a use case that's less understood for the data that we have than the car reservation situation.
Valid point. And then I'm going to immediately switch gears with another non-analogy, and I'm going to talk about what the industrial folks have been doing for 50 years on Modbus and OPC.
Right.
And it's way more complex than they're running nuclear power plants and mission critical stuff. So what's the difference?
A lot less points in the industrial
or
stuff.
Modbus, you don't play in the game.
Right. And the difference is that in those systems that you talked about, they don't have as much scale. So in a nuclear reactor, you can afford to pay an engineer to go into a manual and look at what register X
Because
does.
there's business value there.
Exactly. And I think you just nailed it. And what we don't always have is enough business value. So what we're trying to do is to figure out how to get to scale by making it
There you
simpler.
go. We're
Right?
trying to sell the value of the data integration. If only and then we want to have people figure out that it's a great thing. If only we knew what we are going to do with this beautiful creation that we've created, but we haven't established the business case or the business value.
Well, it's a bit more subtle, and I mean, you know, guys, I've been on this message for a long time, right? Things like the industrial controls, and even the example that you gave with the airlines and the car rentals, they're all literally tied to the revenue that business is running. What we do isn't tied to any revenue, you know, per se.
Right.
The building's purpose is totally aside to the functions that we do inside that particular building, right? Whether it's a hospital or whether it's a school or whether it's an office building. So we are not directly in line with the revenue creation piece, and therefore it always gets sidelined.
Yep. Agreed. And maybe we should be trying to get there. Because the plumbing argument quickly goes away, and people will find budget for something that creates tremendous business value and ROI.
Right.
But to me, that's the whole rationale for thinking about the silo approach of buildings, because the silo approach targets the building owner, the capital owner, the operator that is needing to derive value from the building, from the whole building, not the HVAC, not the lighting, not any specific thing, for the whole thing. And the only way that can be done is for all of the pieces in the whole thing to work with each other.
Well, you know, back in the day, we had it easy. I mean, I literally still can recall having a suitcase demo back in the 80s where I would go to a customer and it had light bulbs on there, and they had a little miniature master supervisor controller. It's like, wow, look at this. You know, I flick a switch and your lights come on. Ooh, wow, ooh. That quickly, I mean, that's a convenience factor. But now we've moved in. It's not amazing anymore to remotely turn on a light bulb. So now we have to move into, you know, what's the value that the building automation system? Well, there is really an EMS. It's an energy management system. Well, is it? You know, and that's where the opportunity has been for me and others over the years, because a building control system is not an energy management system. It doesn't care about energy. It doesn't even know about energy. So that's been that's been like a play that we can use to add that additional layer of value on top. And I think that's why I'm so focused on value creation. That's it.
Yeah, to that point, Anno, do you think we should all go hang ourselves just because there isn't enough value in what we do existentially?
I think it's well, you guys know what I've done, right? Is I've got to tie myself to someone who's actually creating value of the services we build, right? So, no, I think it's, even though I noticed like Jennifer's comment in there about if the building doesn't work, but to be honest, I think we've done a really good job of making the buildings fundamentally work, right? It turns on, it can kind of keep temperature, it can keep the lights on, and we can keep the doors locked. You know, by and large, it works. Now, is it optimal? You know, are we over maintaining it? Are we spending too much on capital? Are we spending too much on energy? You know, all the sundry bits. But we've highly focused on making the building work, you know, from a tenant perspective. And even, you know, Yeah, a hospital you can't, but even in today's world, if my office isn't working, I'll just go home and continue working, right? I've got to work around. When you can't rent that car at all, and I don't have a workaround, I'm kind of stuck, and I make a lot of fuss and noise and carry on, and why can't I rent my car? Because it's critical for me to do what I need to do. Anyway, so I think to your point, Keith, it's okay, beyond making it work, how are we making sure that it costs the least amount of money when we make it work. Costs the least amount of energy, costs the least amount of maintenance, it costs the least amount of attention, people focus to make it do its thing, right?
And if
That's where
and
we're
if
trying to
Rick was on the call today, this is the point where he will say TXO.
That's right, exactly. TXO, total cost of everything. Yeah.
Absolutely.
So what I'm hearing is that because there's not obvious value for many situations, and I know, Keith, you work hard to educate your customers on that there is actual value. Here it is. I'll deliver it for you. But in general, I think Jim's point of why he wants to hang himself is that he struggled over the years to articulate that value, get anybody to believe it and buy it, right?
Right.
So what it argues, I think, is that the effort we've got going with C4SB is to get us as an industry to, instead of fighting each other, to collaborate,
Right.
so that we can produce, I'll call it a solution, an interoperability solution that's really inexpensive and easy to use. So doesn't involve a whole lot of shouldn't involve a lot of whole custom engineering. Companies having to reinvent the wheel over and over again to make it work with their particular brand of stuff. It would allow dissimilar systems to interoperate, meaning lights and security and EV chargers. I mean, you name it, right? So if we're actually successful, I think, in this in the C4SB Linux Foundation efforts to get significant industry partners to collaborate effectively, we might actually be able to produce some results here that meet the objective of easy to implement and at a low cost.
Yep. And we can all die or retire happy.
Exactly.
This group will go down in history as the ones that made it happen.
Made it happen.
Before we die. I've been to the mountaintop.
So it's coming up to wrapping up time. Anybody wants to feel compelled to do a wrap up?
I don't want to do a
some
wrap
news.
up, but I just want to add a few little notes, I guess.
Let's call a wrap
So
up.
the
Go ahead. Go ahead.
The anti-stud concept is I think is something that's interesting. And the other thing we didn't talk about is how, as long as we had APIs that were robust and useful, how successful would AI be at sorting them out? Like if we had hooks and handles out of these systems, that's what we're right on the edge of that. I don't, but I don't know if anybody understands just how powerful AI could be at trying to solve that problem for us. So as we try to beat up the industry to try and come up with some standards, maybe it's not so bad if we can get this information out and have these anti-studs that actually have a stud that they can connect to the existing systems. Maybe there's a solution there, and using AI we can kind of skirt some of this around. I'm not sure. Might be somewhere where we might go with one of our next discussions.
There's some testing going on in the C4SB work for the PAE building. If you're talking about decomposing, this is a perfect opportunity, since we are literally decomposing an existing building and seeing what pieces are in there. and then posting the results of that. So it's an opportunity to even unleash AI on that. Here's some of the Lego pieces we're seeing now that we pulled them out. What can we do with it? And that's a lot of the C4SB work on the PA building.
Yeah, and considering AI as being part of this mix is critically important for us. There's no doubt about that. It's why Kimon's doing that work in PAE, and it's AI becomes another sort of user of this flexibility, just like applications and other humans and companies and owners. So absolutely important. Okay, we need to wrap this. Thank you very much for a great conversation. Thanks, everyone. I think Jennifer was saying now we need those little Lego tools to pry the bricks apart. We need to create a version of that as well. So,
that's a good point.
Good point. Thank you very much. Right, we'll get the video out hopefully today or tomorrow, and have a great Thanksgiving, everyone.
Yeah.
Thanks.
Have a good Thanksgiving.
Bye.
Bye, guys.